Okay, in the next several videos, I'm going to give you lots of examples of common functions. The first one we're going to look at is the absolute of x. Well, it's written like this: x with two vertical lines. So this here is the absolute value of x, or it could be written as this. And this is just a short version of the word absolute. Okay, so let's say we've got a function f of x equals the absolute value of x. So here, if you imagine your number line, what abs means is suppose x equals 3. The absolute value of 3 is the the magnitude of that number from the 0. So here the absolute value of 3 is the 3. It's just the length of this thing here. If you look at, let's say, let's look at when x equals -4. Well, the absolute of -4 is the length or the magnitude from the 0 to here. So in this case, when x equals -4, abs of x here would be 4, because you only care about the magnitude from the 0 to here. You only care about the length from 0 to here. So the magnitude, in a way, it's like you just ignoring the negative sign. So the absolute value of 5 is 5, but the absolute value of, let's say, -1 is 1. So the absolute value of the absolute value of -1 is 1. Okay, so because the absolute value is the magnitude from the 0 to wherever you are. You only care about the length. You don't care about the minus, in a way. Um, when you're older, you would do what's called complex numbers. So you have I, 2i here. Suppose you're here. You see the magnitude, the absolute value of this thing here. Let's say your number is here. Don't worry about complex numbers, just roughly speaking. Let's say your complex number is right here. So the absolute value of your complex number is the magnitude, is the distance from here, from 0 to here. So in which case you have to use Pythagoras, where you have 2 squared here, and then this thing here would be 3 squared, just so that you can find out the magnitude of this thing. So the absolute values is like the magnitude of wherever you are. Okay, so if you try to create a table like this, hang on. Let's say when x equals 0 here, absolute value of 0 is actually 0. Okay, so it will be 0 here. When x is 1, the magnitude here is 1. So this here is 1. When x is 2, the magnitude is 2. When x is 3, is 3. When x is 4, is 4. Now when x is -1, then the absolute value of x will be 1, because you only care about the magnitude. Well, it's going to be 1. When x equals -2 here, it will be 2, because you only care about the length here, the magnitude. Well, when x equals 3, you only care about the magnitude, so it will be 3. And when this here, 4 and 5 and so on. So when you come to plot it, it will look something like this. It will look something like this. So you doing f of x, you plotting the function here, f of x equals absolute value of x, would look like this. When x is 1 is 1, when x is 2 is 2, when x is -1, this thing here will be 1. Okay, when x is -2, this one will be 2. When it's 0, it's 0. So it turns out to be like this. Okay, so the function f of x equals absolute value of x. The function here would look like this. Okay, and it is a function because any vertical line you're only going to get one point. It's not like a graph where it goes back on itself. So therefore, you see, if you draw a vertical line here, you have 3 points here. This is not a function, but this here itself is a function, because if you, no matter what vertical line you draw, it only has one value here. Okay, even at 0 here, so the absolute value of x is itself a function. So you can say this is a function. Okay, but also another thing is, suppose you have like f of x here equals the absolute value of x. Our transformation still works. For example, if you have, let's say, g of x equals absolute x negative, minus 2 here, the absolute value of this, well, again, it's like transformation here. You are in a way shifting everything to the right by 2. So your new function, your graph here will look like this. It will be the same thing. Okay, so it will look like this, and you could have, hang on, you could have let's say this here is hang on, let's say this here is f of x equals absolute value of x here. You could actually have this f, you could actually transform it, so it's x minus 2 and then plus 3. So in which case you move it to the right by 2 and then you shift it up by 3. So your new well, you shift it to the right, so it will be like this. Okay, and then you add 3, so your new graph will look like this. Removing, well, let's remove this here. So if we move it up here, it will look like this. My point is that my point is that if you have a function f of x equals absolute value of x here, it will look like this. Okay, and my point, that's a bit ugly. So it would be like this. So this function here will look like this. My point is that if you can actually apply transformation to this. So if you have a new function, absolute of x plus 2, and then you can add 5. You can actually use transformation to actually draw this function here. Okay,